Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the multiplication rule for probability when we're working with independent events. So there are two parts of the multiplication rule depending on whether your events A and B are dependent or independent. So we're going to take a look in this video at the situation that they're independent. So if two events A and B are independent, in other words, one event doesn't depend on another, or another way to think of it is the outcome of one event will not affect the outcome of the other event. So if they're independent, then the probability of A and B happening will be equivalent to the probability of A happening times the probability of B happening. And means at the same time, and order isn't important. I want to just introduce some notation that you're going to see when you're working with multiplication rule with dependent events. It's also called conditional probability, and that's this notation here. So the probability of A, this line means given B, is equal to the probability of A if the events are independent. It means it doesn't matter if B happens or not. Probability of A, regardless of B, is just the probability of A. Similarly, the probability of B given A will just be the probability of B. It doesn't matter if A happens or not, if the two events are independent. Let's take a look at some examples. Our first example says you've tossed two coins, and it's asking what's the probability of tossing two heads. So you first determine that they are independent events, and the way that you know that is that the outcome of one coin toss will not affect the outcome of the other coin toss. They're totally independent of each other. So the probability of A and B will be equal to the probability of A times probability of B. So event A would be one head, or heads for the one coin, and B would be heads for the other coin. We can then calculate these two probabilities. Probability of the first coin being a head would be 1/2, and the probability of the second coin being a head would be 1/2. So the probability of two heads would be 1/2 times 1/2, which is 1/4. But what I'd like to do is introduce what's called a tree diagram, because a tree diagram organizes the information nicely, and it gives you a lot of information to look at if you were asked for other probabilities as well. You know, the probability of two tails, or the probability of a head and a tail. So let's take a look at what a tree diagram looks like and how we can use that. With a tree diagram, we start off with one coin. There's two options, or two possible outcomes. That coin is either a head or a tail. Then what we're going to do is we're going to attach probabilities to each of these, and you can write them as fractions or decimals. I'm going to write it as decimals. So there's a 0.5 chance that it's a head, and there's a 0.5 chance that there's a tail. When you use a tree diagram and you list all the possible outcomes and their probabilities, remember all of those probabilities have to add up to equal 1. Then you have a second coin you flip. It's possible two outcomes are a head or a tail. Again, the probability of a head is 0.5, probability of a tail is 0.5. If the first toss is a tail, or the first coin toss is a tail, again, there's two options for the second coin, a head or a tail. Again, 0.5 and 0.5 are the respective probabilities. So there's only one limb that we're going to take a look at where we toss two heads, a head and a head. So we're going to take a look at that branch of the tree, and the probability of two heads, or probability of HH, will be equal to 0.5 times 0.5, which is equal to 0.25. You don't need to make the tree diagram. It just might be helpful, especially if you're asked to find a lot of different probabilities about this event. Let's take a look at tossing 3 coins. Our next example says you toss 3 coins. What is the probability of tossing 3 tails? as it gets more complex, I am going to use a tree diagram, especially because if I was asking what's the probability of tossing 2 tails and 1 head, it gets a little more complicated than just tossing 3 tails. So let's take a look at our tree diagram and answer this question, and then I'll answer another question that's a little bit more challenging. So our first toss, first coin is either a head or a tail. 50% chance for each. Then the second coin toss is either a head or a tail. So if the first coin is a head, then our 2 options for our second coin are head and tail, so 0.5 and 0.5. Similarly, if our first coin is a tail, then our second coin could be a head or a tail. And then for our third coin, we have a head or tail option for each of these branches. So these probabilities are all 0.5 as well. So now we look at the series of branches that give us the 3 tails. So the first toss would have to be a tail, the second toss would have to be a tail, and then the third toss. So this here is what we're interested in. The probability of 3 tails will be equal to the first probability of 0.5 of getting 1 tail. And then after that, probability of 0.5 to get a second tail. And third coin, probability is 0.5. When we take that product, it's 0.125. So we still are tossing 3 coins, but now we want to know what's the probability of tossing 1 head and 2 tails. So for this one, I have to look at each series of branches that will give me that outcome. So let's take a look at how the different ways we can get 1 head and 2 tails. To start off with, we could have our first coin being a head, then the second coin and the third coin being a tail. So there's one way we can get it. Then we can get 1 head and 2 tails if we get a tail on the first coin, a head on the second coin, and then a tail there. So this will give me the outcome. The third option is if the first coin is a tail, second coin is a tail, and the third coin is heads. So there's 3 different ways we can get that desired outcome. So the way we're going to set it up, we're going to use our addition rule as well. So we can get 1 head and 2 tails this way, or this way, or this way. And when we've got an or situation, we add. So our 3 probabilities, we get these by multiplying. Here we get the probability of doing it this way by multiplying. We get the probability of doing it this way by multiplying. And then we add all 3 of those probabilities up. Let me show you what I mean. The probability of 1 head and 2 tails. So now we're going to find the probability of getting 1 head and 2 tails. The order doesn't matter. So there's 3 ways we can do it. I don't have enough room to put it all on one line. So I'm going to put my equals there, and then I'm going to start with the first way I can do it. That would be as if my first coin was a head, the second coin is a tail, and the third coin is a tail. Plus, second way I can get it is if the first coin is tails, then heads, then tails. So that's 0.5 times 0.5 times 0.5 as well. Or, so plus, the third way I can get it is if I get 2 tails and then a head. So this probability will be equal to 0.125 plus 0.125 plus 0.125, which is 0.375. You have to be careful and make sure you've got all of the possibilities to get that outcome. Okay, next example says the probability that it will rain tomorrow is 0.15 or 15%. And then for the next day after tomorrow, it's 0.2 or 20%. And then for the third day, it's 0.3 or 30%. The question says, what's the probability that it rains tomorrow and the next day, but doesn't rain on the third day? So the probability of all these events, so we'll say A and B and C will equal the probability of A times the probability of B times the probability of C. So let's find each of these probabilities. A will be that it rains tomorrow. So the probability of that happening is 0.15. The probability that it rains the next day will be 0.2. And event C will be it doesn't rain on the third day, but the probability that's given is for rain on the third day. So if we want to have our event C be in that it doesn't rain, remember that's the complement of this event, raining. So the way that we find that is 1 minus 0.3. In other words, if the probability that it will rain on that day is 0.3, that means that the probability that it won't rain is 0.7. So just be careful with that when you're finding the complement. So the probability of A and B and C so we use the intersection symbol for and, will be the probability of A, which is 0.15, times the probability of B, which is 0.2, times the probability of C is that it doesn't rain, is 0.7. And when we multiply those together, we get 0.021. So about a 2.1% chance that it'll rain tomorrow and the next day and not rain the third day. Our last question says you have 3 red and 6 green candies in a bag. You choose one candy and then place it back in the bag before choosing a second candy. What is the probability of choosing 2 red candies? So I have 3 red candies, 5 green candies in the bag. So the probability of choosing red and red, when I've got the same candies to choose from each choice, would be 3 out of 8 for the first red, and then 3 out of 8 again. So the probability of choosing the first one red and the second one red when I put the first red back would be 9 over 64. However, often with questions, you're not going to have replacement, you're going to have without replacement. So the question could be, you choose one candy and you don't place it back in the bag and then you choose a second candy. Well, obviously, whatever you choose for the first candy is going to affect the probability for the second outcome. So I just want to do that as an example. These are called dependent events or conditional probability. So I just want to briefly do that with a tree diagram, and then we'll explore the topic further in my next video. So we changed the question a little bit. You have 3 red and 5 green candies in a bag. You choose one candy and then a second candy without replacing the first. What is the probability of choosing 2 red candies? In order to do this without using the formula, I'm just going to do a tree diagram. So when I choose my first candy, it's either going to be red or green. Let's write the probabilities. To start with, when I have all 8 candies, the probability of choosing red is 3 over 8. Probability of choosing green is 5 over 8. Remember, these two have to add up to a 1. Now, if I chose red, now I only have 2 reds and 5 greens. So then my probability of choosing a red on the second candy will be 2 out of 7. The probability of choosing a green will be 5 out of 7. Let's take a look at if I had chosen a green candy first time. Then I'm left with these 7 candies. So my second choice, the probability of choosing a red out of these 7 will be 3 out of 7 for red. And for choosing a green, the probability would be 4 out of 7. Again, these 2 probabilities add up to 1. These 2 probabilities add up to a 1. So if I wanted to know the probability of choosing a red and a red, it will be 3/8 times second red 2/7. So that's going to be 3/28. So this is going to be a little bit different than when you're working with independent events. And I want to get into the notation and the explanation and more examples in my next video. I'll see you then.